What I was thinking was, since everything would be offline starting April 1, we can have an offline quiz on April 2, right? In one of the, does that sound, huh?
What about the 26? What about the 26?
26 will not have anything, right? The 26 quiz would be on 2nd. That's what I'm saying. That's what I'm proposing. If it suits all of you. Is that fine? Because 26, if I take an offline quiz, there may not be, there's a possibility that some of you may not be there, right? Or some of you may have planned to come on April 1. So keeping that in mind, suggesting that we can have a quiz on April 2, which is Saturday. So we'll ask for one of those lecture rooms, and then by maintaining proper social distancing, we can have a quiz on April 2. Does that sound good? Or does anyone has issues with it? Yeah? Is that fine with all of you? Or? Yeah? Don't hesitate. If you're not comfortable, you can always. I was expecting some of you to say that. Huh? It's. But how does that help? The only way it can help is you may collaborate, right? Some of you. Otherwise, writing in there or here, how does it matter? What you can have, you open? Right. You can do that, means I don't mind doing that, but with that rider it's fine, or still you prefer online? But your final exam is anyway offline, that you are aware. But if you insist, I can go for online. That's not an issue for me. If you want, if most of you want online, that's fine with me. Online you want, most of you? How many of you want online? And now, yeah, now you can raise it. Yeah, this most of you, or I see half of you are doing half-heartedly, right? So, okay. So okay, so we can have online, but let us keep it on 2nd itself, right? Because I don't want if some of them are planning to join here on 1st, they may be traveling and so on. So is that okay, 2nd? So we can have online, but the end semester would be totally offline. So we were planning to do this Ump Alpha Test for any doubts anyone has? Does anyone has any doubts? If not, then we can move to the next topic, which was about deriving UMP tests for certain one-sided composite hypotheses. So what we are interested in testing is, I have H0 theta less than or equal to theta naught versus H1 that theta greater than theta naught. A dual of this hypothesis would be that you're interested in testing H0 that theta greater than or equal to theta naught versus H1 that theta less than or equal to theta naught. Let us talk about situations where I have a statistic Tx which has MLR. Now you know that if T has MLR, that pretends that larger values of T stochastically corresponds to larger values of theta. So for this kind of hypothesis, you would reject for larger values of T. And in this case, alternative is smaller values of theta. So you would reject H0 for smaller values of T. And that is what exactly the next result says. Suppose X has PD of F, which belongs to the family of PDFs, F theta. Theta belongs to theta, where theta is subset of R, so it is a one parameter family. And suppose this has MLR in some status T, which I'm writing down as Tx. So consider testing H0 that theta less than or equal to theta naught versus H1 theta greater than theta naught. Note that the case where you have such kind of hypothesis can be dealt with absolutely in the same manner, right? Except that inequalities would change. Then the first part says there exists a UMP alpha test given by phi star x, which is equal to 1, if T is greater than C, gamma if T is equal to C, 0 if T less than C, where C and gamma, which is between 0 to 1, is determined by E theta naught of phi star T is equal to alpha. Or in other words, what is expected value of phi star T? Phi star x, you can write it down because I'm writing down everything in terms. What is expected of phi star x? 1 times probability that T is greater than C plus gamma times probability T is equal to C. So that is probability under theta naught T is greater than C plus gamma times probability under theta naught T is equal to C. Now you know such a thing would always exist, right? Such a thing would always exist because this is a decreasing function of C. So as C goes to infinity, this is 0. I start from infinity, keep on decreasing it. Since it is decreasing from T greater than C, it is 0, right? So that means I'll have to have something bigger over here to achieve it to alpha, right? I have to have a bigger, that means what should I make to C? Smaller, right? So I make it smaller and there's a possibility that still I am less than alpha. I go to the next C and I keep on going until C where I have reached alpha. If there is exact one C, it is exactly alpha, then gamma is 0. You don't have to do that. But in discrete cases, that may not be possible. There is a possibility that there would be one C where it is less than alpha. And the moment you go to the next C in the discrete distribution, it becomes more than alpha. So you have to stop at a point where it is less than alpha, and then you adjust gamma so that everything is together alpha, right? And such a gamma is always between 0 and 1, that you know, that we have already seen. So existence of such a C always is always there, right? Now let us see. So this gives me UMP alpha test for this kind of hypothesis. Now what would happen for this situation? Exactly the same. It would become T less than C. Gamma if T is C, 0 if t is greater than c, such that this is alpha. It will become probability that here it was less than c, so 1 times probability t less than c plus gamma times probability t is equal to c is alpha. Exactly the same way, with just inequalities and changed. Second thing is beta phi star theta is strictly increasing Yeah, these are part B. So power function of this would be strictly increasing for all thetas for which beta phi star theta is between 0 and 1. This is another nice thing. That means power would be strictly increasing function, power function. So that means at theta naught, if it is alpha, so at all the points in alternative hypothesis, it would be bigger than alpha, right? Because it is strictly increasing. So beta phi star theta would be greater than beta phi star theta naught if theta is bigger than theta naught. So that means for all points under alternative hypothesis, your power would be at least same as the level of significance, right? Not only that, this test also minimizes the type 1 error among all tests for which size is exactly alpha. That means, so primum over beta phi star theta is alpha. Among all such tests, this test also minimizes the type 1 error. For any theta less than theta naught, phi star minimizes beta phi theta, which is a type 1 error probability. Among all tests phi, satisfying actually note that for UMP alpha test, you want probability of type 1 error to be less than or equal to alpha. Right? Right. What it says is if somebody has used the maximum liberty up to alpha, then for all such tests, this test, which uses the maximum liberty, also minimizes the type 1 error. Right. So the only error, the only test which can minimize type 1 error is you compromise on the type 1 error, you make it less than alpha, but then there is a possibility that this would increase. Right? Any doubts on this? Are you understanding? Try to understand each and every statement which is being written statistically. For any theta 1 belonging to theta, note that this test was of size because beta phi star theta naught was alpha. Suppose I look at another theta 1. Beta phi star theta 1 would be some quantity. Right? So if I have to test H naught that theta less than or equal to theta 1 against theta greater than theta 1, then this test is also uniformly most powerful for testing such a hypothesis, except that now the label becomes beta phi star theta 1. For any test, for any theta 1 belonging to theta 2, phi star is UMP alpha for testing H naught at theta less than or equal to theta 1. UMP alpha star, let me put, versus H1 that theta greater than theta 1 with your alpha stars would be same as what? Whatever is a type 1 error at theta 1 for this test. So this tells you a lot of nice properties about test phi star. You can use the same test 5 star at different level of significance. Or you can use the same test for testing different kind of hypotheses. Theta less than or equal to theta 1, theta greater than theta 1, except that now your level would change. Level would depend on what is the value of beta 5 star theta at theta is equal to theta 1. You can use the same test. Is that okay? Pi number? So, have a uniformly most powerful test, right? A natural question arises, can I say something about its type 1 error? I know its type 1 error is bounded above by alpha, right? But it, among all tests, it uses the maximum liberty to go type 1 error up to level alpha. It says if you consider any all such tests which have that liberty, that they can have their level up to alpha, then for that test, this also minimizes the type 1 error. You see, because type 1 error may not be alpha, right? At some theta, it may be less than alpha. So any other level alpha test you consider, it would have some less than, some not alpha, some it would be less than alpha, but something else. So what I'm saying is among all such tests, this would have a minimum type 1 error probability. Okay. The only way it cannot minimize type 1 error is you are using a level alpha, but you are using at some lower level, and then there is another uniformly most powerful test that we have seen situations where you might have a test with level exactly equal to alpha, having power 1, and something less than alpha also having power 1, right? But if you are using the maximum liberty, so you are considering only those tests for which, let us say, size is alpha. For all tests having size alpha, this test would minimize the type 1 error also. That is what it means. Is that clear to everyone? You see, level of significance may not be same as size. What is a size? Size is the same as supremum of probability of type 1 error. Right? So size is same as level of significance. That means supremum is same as alpha. Is that okay? So that is what it's saying. Beta 5 star theta, for any theta less than or equal to 5 star minimizes beta 5 theta among all tests satisfying beta 5 theta not equal to 1. So it says something more than that, in fact. It doesn't even say that this class of sets test may be larger. Size is alpha means supremum is alpha, and it is increasing. So it is much stronger than that. Among all tests for which beta 5 theta naught is alpha, this test minimizes the type 1 error probability. Okay, let us try to do it one by one. So let us consider f theta 1x upon f theta naught x. So first I do is consider testing h naught that theta is equal to theta 0 versus h1 that theta is equal to theta, where theta 1 is bigger than theta. I know that UMP alpha test always exists, right? So if I look at f theta 1x minus c, I know that this is an increasing function of tx because it has MLR. Is that okay? Because f theta 1 upon f theta has MLR in tx, that means f theta 1 upon f theta 0x is increasing in tx. So what would be the UMP alpha test? You see, if you look at what you were looking at earlier, you were looking at the quantity of the type f theta 1x minus c times f theta 0x. You are trying to look at when it is greater than 0 and when it is less than 0. Right? So what I do is I take out f theta 0x outside. I can write down this as f theta 1x So how does your test look like? So UMP alpha test when this is greater than 0, right? Pi star x this is greater than 0. So I look at all the points where f theta 0x is positive. Then this is greater than 0, right? Both should be positive. This is greater than 0 is equivalent to saying that because it is an increasing function of tx, so that would be same as saying that tx is bigger than some constant c. And 0 if tx is less than c. By the same logic. Is that okay? And then gamma if tx equal to. Actually, what you know is first write down UMP alpha test is phi star x is equal to 1 if f theta 1x, just applying the name and PSL value, is greater than k times f theta 0x. 0 if f theta 1x is less than k times f theta 0x. Because if I star is UMP alpha, then it would be of this type. So now f theta 1x, so let me write down over here k, right, so that you have a different c over there. This is no, you know that this would be 1 when this is greater than 0. This is greater than 0. One possibility is that f theta 0 is 0 and f theta 1 is positive. Right? F theta 0 is 0 and f theta 1 is positive. The other possibility is I take f theta 0, this quantity is positive. This quantity is positive because f theta 0 is positive, so this is positive. But f theta 1 upon f theta 0 x is increasing. So f theta 1 upon f theta 0 minus 1 is increasing. So that quantity bigger than 0 is equivalent to saying that tx is bigger than some quantity, right? Which is equivalent to saying that. That I'm not pausing. There I have a liberty. I can put anything as long as I'm able to satisfy that, right? So this is 1 if t is bigger than c, 0 if t is less than c, right? And I can put because I have a liberty, as long as there is an existence, I can put gamma if t is equal to c. And where e theta 0 pi star t is equal to alpha, right? Which means p theta 0 t greater than c plus gamma times p theta 0 t is equal to c is alpha. But this only shows that it is most powerful test for testing theta is equal to theta 0 against theta is equal to theta 1. Does this test depends on the choice of theta 1? So let us look at the test is this. It has no theta 0, no theta 1. It has only c. So there is a possibility that c may depend on theta 1 or theta 0. But I see that c is determined only through distribution at theta 0. So c only depends on theta naught. C only depends on theta. So that way, the above test which is uniformly most powerful for testing theta is equal to theta 0 against theta is equal to theta 1, does not depend on theta 1 as long as theta 1 is bigger than theta naught. That I have used. Theta 1 bigger than theta naught I have used because MLR I have used. So that means the same test would have the maximum power, right, as long as I take any theta 1 which is bigger than theta naught. So, or in other words, the same test should be uniformly most powerful for testing theta is equal to theta 0 against theta greater than theta naught. Theta greater than, is that okay? Is that clear? Because that you have to understand. Because you see, what you're trying to do, you're trying to maximize the power. So what I'm saying is, as long as I'm considering any theta 1 bigger than theta naught, the power of this test is maximum. So I can choose any theta, power would still be maximum, but when you're considering the hypothesis theta is equal to theta 0 against theta greater than theta naught, you're considering powers at the point theta greater than theta naught. But for any point theta greater than theta naught, this test has a maximum power, right? For testing theta is equal to theta naught against theta is equal to theta 1. So this test, so 5 star does not depend on theta naught. Or in other words, among all tests for which beta phi theta naught is alpha, this test has maximum power at any theta bigger than theta naught, because it does not depend on the choice of theta. So what does that mean? This implies that 5 star is UMP alpha test for testing now. I cannot claim that this test is uniformly most powerful test for testing theta is equal to theta naught against theta not equal to theta naught. Why? I cannot say that this test is uniformly most powerful for testing theta is equal to theta naught against theta not equal to theta naught. You see, it does not depend on theta 1. That is not fully true. That only half true. It does not depend on theta 1 as long as theta 1 is bigger than theta naught, because that is where MLR you have used. Because this is greater than C is equivalent to that T is greater than C is equivalent to saying that for theta 1 greater than theta naught, this is an increasing function. So this does not depend on theta 1 as long as theta 1 is bigger than theta naught. Right? And that is why it would be uniformly most powerful for testing this versus this. Now what remains to prove? What remains to prove? I have to prove that it is also uniformly most powerful for testing theta less than or equal to theta naught against theta greater than theta naught. So what should I prove? Certainly power is taken care of. It is only the type 1 error I have to take care of. So that is the only thing I have to show is beta phi theta should be less than or equal to alpha for every theta less than theta naught. Yeah. Only when theta 1 is bigger than theta naught.
So if we take normal 0, 1, standard normal and normal some 2, 1.
Normal 0, 1 and normal 2, 1. Yeah.
So it may happen that if theta, it will draw a picture.
No, it will not. It will always be increasing. Let us look at what. So you are saying normal 2, 1, normal 0, 1, right? What is the normal 2, 1? 1 by root 2 pi e to power minus x minus 2 whole square by 2. Is that okay? By root 2 pi e to power minus x square by 2. E to power minus x square by 2 gets cancelled. And above only positive power of x comes. So it is an increasing. Normal has MLR. All exponential families would have MLR, right? Yes, any other doubt? Because this is very important to understand. This is a very subtle point, but very straightforward. But so that means the only thing I need to show is it has level alpha. Level alpha means beta phi theta should be less than or equal to alpha for every theta less than or equal to theta naught. So that means its maximum beta phi should be at theta naught because that is where it is alpha. But I know that if my distribution has MLR, then expected value of psi is increasing for any increasing function. So if I can show that my beta phi theta, if I can show that this is an increasing function of t, I am done. Let us look at phi star t. Is it an increasing function or not? Very clear, right? It is 0 up to certain point, t less than c. T is equal to c, it gives a jump, gamma, which is again between 0 and 1. And then for t greater than c, it goes further 1. So it is a non-decreasing function of t. And you know that if a family of distributions has MLR, then its expected value is increasing. So this implies that E theta phi star t is an increasing function of theta. Any theta, right? Whether in alternative or null, doesn't matter. It is anyway increasing in theta, or any theta. What does that mean? That means beta phi star theta would be less than or equal to beta phi star theta naught for every theta less than theta naught. And what is beta phi star theta naught? Alpha. For every theta less than or equal to theta. So this test is of level alpha. It also maximizes type 2 error at every theta in the alternative hypothesis. So it is UMP for testing H naught theta less than or equal to theta naught against theta greater than theta naught. So this implies that basically this implies that phi star is of level alpha. This implies that phi star has level. All right. It has level alpha, it has maximum power, so it is UMP alpha test. So that proves the part 1. Now let's try to prove the part B. So let theta 1 is less than theta 2. I have to show that it is strictly increasing. This says that beta phi star theta I is between 0 and 1 strictly. What I have to show? I have to show that beta phi star theta 1 is strictly less than beta phi star theta 2. Okay? So consider testing H naught that theta is equal to theta 1 against theta is equal to theta 2. Then what can you say about phi star? Phi star would be UMP alpha, except that now my level would be beta phi star theta 1, right? Because the nature of the test is same, right? Because for any theta 1 again, it would be of the type t greater than c, gamma if t is equal to c, 0 if t is less than c, and c is chosen so that beta phi star theta 1 is same as alpha. Right? So now I change alpha, that means my alpha now has become alpha star, which is beta phi star theta 1. So then phi star is MP alpha star, where alpha star is nothing but beta phi star theta 1, which is E theta 1 of phi star. What I do is I consider the no data rule. Of course, this is between 0 and 1, right? Strictly between 0 to 1, because I have taken my beta phi star theta i's to be between 0 and 1. Right? Now consider no data rule, which is phi naught x is same as alpha star. I have to show that beta phi star theta 1 is less than beta phi star theta 2, right? What does no data rule means? A rule which does not uses data at all. Right? It says I'll not use any information. So it's what this rule says is you take a coin where probability of head is alpha star, toss a coin. If head turns, I'll reject hypothesis. If head doesn't come, I'll accept hypothesis. That is what it means, right? Because phi naught x is a probability of rejecting h naught, depending on x. He says whatever x may be, I'll reject my h naught only with probability alpha star. What does that mean? That whatever observation may be, I don't care. I will always toss a coin with probability of head as alpha star. And if the result of such a toss is head, I'll reject h naught. Otherwise, I'll not reject h naught. That is what it says. Then what can you say about E theta 1 phi naught x? This is alpha, right? E theta 1 phi naught x is alpha. What does that mean? This has level alpha. But phi star is UMP of level alpha. So that means this has level. This implies that phi naught has level alpha. Sorry, alpha star. Which implies that E theta 2 phi naught x is a power, because phi star is uniformly most powerful alpha test. So power of phi naught would be less than or equal to power of, because both are alpha level test and phi star is uniformly most powerful alpha test. So this would be less than or equal to E theta 2 phi star x. What does that mean? This is nothing but alpha star, because phi naught x is always alpha star. It does not depend on x. Less than or equal to E theta 2 phi star x. Which is obvious, but I have to prove that this is strictly increasing. So I have to prove that this is strictly less than. So I have to show that equality cannot attain. Now, when do you have equality? I have equality when phi naught is also most powerful test, because that is the power of phi naught is same as the power of the most. You know, UMP alpha tests are almost unique if are only on the set f1 is equal to x equal to k times f naught x. So what does that mean? This implies that phi naught is also MP alpha. So by uniqueness of MP alpha. What should be my phi naught x? One, if f theta 1x is greater than k times f theta 2x, and 0 if f theta 1x is less than k times f theta 2x. But phi naught x is always alpha star, which is always between 0 and 1, right? Because my beta theta 2 was also always between 0 to 1. So what does that mean? That means these steps will never occur. These regions will never occur. So what does that mean? That means your f theta 1x has to be same as k times f theta 2x all the time. Because this has to be always, because this is 1 and this is 0, but my alpha star is always between 0 to 1. So this implies that almost, sorry. But both are densities. They have to integrate out to 1. Right? So what should be k? Because this will happen for all x. This implies that k is equal to 1. K is equal to 1 means f theta 1x is same as f theta 2x. So that means the densities cannot be discriminated, which is equivalent to saying that theta 1 is same as theta 2. Right? So this doesn't happen. Okay, so what was the, this was part B. The C part was, let me just see the C part. Strictly for any, it minimizes the probability of type 1 error, right? Which one? Yeah, theta 1 and theta 2. Sorry, f theta 2 is greater. Yes, you're right. Yeah. Yeah, thank you. Now I have to show that this test minimizes the type 1 error probability, right? Also, right? Among all tests for which beta phi theta naught is 1. So for that, let us try to choose theta's double naught, which is less than theta naught, because that is what I have to show. It minimizes type 1 error probability. That means I have to show that beta phi star theta naught, theta double naught, which is less than theta naught, should be less than or equal to beta phi theta naught for any other test phi for which beta phi theta naught is alpha. Let theta naught, so I have to show that phi star minimizes this quantity among all test phi satisfying beta phi theta naught is equal to alpha. And let phi be a test with beta phi theta naught is equal to alpha. Because I know that beta phi double star theta is also alpha, right? So if you have any other test for which beta phi theta naught is alpha, I have to show that probability of type 1 error of such a test would be larger than the probability of type 1 error of. So that means I have to show that what is the probability of type 1 error? Beta phi theta for theta belonging to alternative. In this theta double naught, I have taken in the alternative because, sorry, in the null hypothesis, theta less than or equal to theta naught. So I have to just show that beta phi double star theta double naught is less than or equal to beta phi theta naught. Is that okay? Now consider testing H naught, that theta is equal to theta 0, versus H1, that theta is equal to theta double 0. What would be UMP 1 minus alpha test? So here alternative you have theta 0 0 less than alpha. So here and you have MLR. So you reject for smaller values. So you reject if 1, if t less than c, gamma, if t is equal to c, and 0. If phi is a test, 1 minus phi is also a test. So the earlier one becomes, earlier phi star becomes, when I convert into 1 minus phi star, it would be 1 if t is bigger than c. No, 1 if t is less than c. 1 minus gamma if t is equal to c. And this is, so that is of that. And what is the label of that test? 1 minus alpha. So that means the same test with 1 minus would become a uniformly most powerful test over here, except that label becomes 1 minus alpha. Is that okay? So UMP, or if you want to do it, you can just, I have given you a reasoning, but if you want to write it down everything, that is also fine. So UMP 1 minus alpha test is, let me call this as phi double star is equal to 1 if t is less than c star, gamma star if t is equal to c star, 0 if t greater than c star. And how you have to choose this c star such that beta phi double star at theta naught is 1 minus alpha. All right. What does that mean? That means p theta naught, t is bigger than, t is less than c star, plus gamma probability under theta naught, t is equal to c, sorry, gamma star, is equal to 1 minus alpha. What does that becomes? Yeah. So what does that mean? That means 1 minus phi star becomes 1 minus phi star is 1 if t is bigger than c star. 1 minus gamma star if t is equal to c star. And 0 if t is less than c star. And what would be beta theta naught 1 minus phi double star? This is expected value at this. So 1 minus that would be alpha. So this would be. So what would be this c star? This c star would be same as the earlier c. Right? Because there also the nature of the test was exactly this, and c was chosen so that this quantity, expected value of this quantity is alpha. So that shows that 1 minus phi double star is same as phi star, with the role of 1 minus gamma star being taken by gamma over there, right? So this implies that phi star is exactly same as 1 minus phi double star. Now let phi naught be any other test of level alpha. For testing H naught that theta less than or equal to theta naught versus H1 theta greater than theta. I think I can continue from here because there's still some arguments involved. I don't want to rush on those arguments. I can do it tomorrow.